Good afternoon, everyone. This is the pre-launch news conference for NASA's Mars Science Laboratory with the Curiosity rover to be launched on Saturday aboard a United Launch Alliance Atlas V rocket from Complex 41. And here to talk about the launch and the mission and look at our weather forecast for Saturday, we'll begin with Colleen Hartman, the Assistant Associate Administrator for the Science Mission Directorate at NASA headquarters in Washington. Omar Baez, the NASA Launch Director from the Kennedy Space Center. Vernon Thorpe, the Program Manager for NASA Missions from United Launch Alliance in Denver. Pete Teisinger, the MSL Project Manager from the Jet Propulsion Laboratory in Pasadena, California. And Joel Tumbiolo, Launch Weather Officer from the 45th Weather Squadron at Cape Canaveral Air Force Station. And we'll begin first with remarks by Colleen Hartman. Colleen?
Thank you, George. Sir Isaac Newton wrote in a letter to Robert Hooke, "If I have seen farther than others, it is by standing on the shoulders of giants." NASA's past is filled with giant accomplishments, and yet occasionally I'll hear the rumor that NASA's glory days are all in its past. The launch of the Mars Science Lab and the rover Curiosity this Saturday, and NASA's successes just this last year show how very, very wrong that rumor truly is. Just this last year, NASA in space and Earth science has had a series of firsts, and these include our international partners as well, so I'll just go through some quickly. A NASA spacecraft was the first to ever go into orbit around the planet Mercury. We launched a mission which is now looking at sea surface salinity of the world's oceans. We launched a mission to Jupiter. We launched and put into orbit a spacecraft around an asteroid, Vesta, and that same spacecraft will go on to a second asteroid in the main belt. So really a 2-for-1. We launched twin spacecraft to the moon, and we launched a new prototype of weather satellites around the Earth. And right now today on pad 39B sits a giant, an Atlas V launch vehicle. And on the shoulders of that giant rests the Mars Science Lab and the rover Curiosity awaiting its 8.5-month, 60 million mile journey to the red planet Mars. And we have gotten here today not just by the hard work of scientists and engineers, but by thousands of other people, of secretaries and support assistants and shop managers and welders, and NASA would like to thank each and every one of you and the families that support you for this amazing technological achievement. Now, Mars really is the Bermuda Triangle of the solar system. It's the death planet, and the United States of America is the only nation in the world that has ever landed and driven robotic explorers on the surface of Mars. And now we're set to do it again. And this rover, Curiosity rover, is really a rover on steroids. It's an order of magnitude more capable than anything we have ever launched to any planet in the solar system. It will go longer, it will discover more than we could possibly imagine. But this is just the first step in a journey, not the end by any means. NASA is partnering more closely with international collaborators in order to prepare to return samples from Mars to the most sophisticated laboratories on Earth to do detailed analysis in preparation for one day sending humans to Mars. And I dearly hope I'll still be alive to watch when that astronaut steps down on that rung to the very last rung and puts her boot in the red regolith of Mars. American men enabled us to go to the moon, but many parts of humanity will be required in order for us to send humans safely to Mars. So now, the Mars Science Lab and rover Curiosity is locked and loaded, ready for final countdown on Saturday's launch to Mars.
Thank you, Colleen. And now to the NASA Launch Director, Omar Baez. Omar.
Thank you, George, and good afternoon, everyone. Thank you for attending this afternoon's brief. I'm very humbled to be here representing scores of men and women from NASA, the Launch Services Program, the Jet Propulsion Laboratory, and our partners at United Launch Alliance. These folks have been dedicated to analyzing, fabricating, assembling, and preparing and testing the Atlas 541 and the Curiosity rover on this MSL mission. We are set to launch this Saturday at 10:02 a.m. A little bit about the rocket. We've got an Atlas V. We call it AVO-28. It is a two-stage mission utilizing a single-engine Centaur. We have 4 solid rocket motors. This is the first flight of that configuration. We had the booster and second stage arrive on July 29th. This was the first time that we used the Foss Mariner, the ship that usually brings in the Delta cores. We used it for the Atlas for the first time. We used to use the Antonov aircraft, and the operation was significantly streamlined by doing this. I'm going to show you about 2.5 months of work in about a minute and a half here. If they would roll the video for me, please, of the rocket going up. This is the Atlas booster, which we started erecting on September 8th. The nozzles at the bottom are the business end of the rocket. That's the RD-180, which burns kerosene and liquid oxygen. Here are one of the 4 solid rocket motors I spoke about. They're about 67 feet tall and 102,000 pounds at liftoff. The combined thrust of those 4 solid rocket motors and the RD-180 is roughly 2 million pounds of thrust at takeoff. Here is the Centaur, which was erected on the 21st of September. The Centaur, after completing both of its burns, gives us enough thrust to leave the planet and head to Mars. We'll be going at about 22,500 miles per hour equivalent at that point when we separate the Atlas Centaur from the MSL or the Curiosity rover. Here is the Curiosity rover within the encapsulated payload fairing. This occurred about 2 weeks ago. We set it down on the Atlas and started our testing, our integrated systems test. Everything checked out well. We then proceeded with putting in the very special battery for the Mars Curiosity rover. That activity started last week. On Friday, we held our flight readiness review, and it was very successful, but at the very end, we received word that during routine monitoring of the flight termination system batteries, we had an indication that one of the batteries was going bad. And so we started activating a pair of batteries. We removed the battery that was going bad, sent it back to get inspected. And unfortunately, the time that it takes to activate the batteries and install it on the vehicle, it cost us 1 day. And that's why we slipped the launch from the 25th to the 26th. This past Sunday, we held our mission dress rehearsal to exercise the team and their communications so that we're right on the money this coming Saturday. We held our launch readiness review today. No actions came out of that, and we're clean and ready to go. We plan on rolling out the vehicle out of the vertical integration facility on Friday morning. We should be on the way to the pad by 8 a.m. We will then connect the electrical, fluid, pneumatics, and environmental control system to the launch vehicle and the MLP. On Saturday, the team will power up the Atlas and Centaur at 3 in the morning. We'll start our flight control checks and facility chill down. My launch management team will be in place at 5:30 a.m. for call to stations. We will receive a weather brief at 7 a.m. We will then clear the launch complex and begin the first hold at T-minus 2 hours. This is a 30-minute built-in hold. At the conclusion of that hold, we will pull the team for concurrence to proceed into cryogenic tanking, and the tanking should start shortly before 8 a.m. After this is complete, we will enter a 10-minute built-in hold at T-minus 4 minutes. At T-minus 11 minutes, the spacecraft will transition to internal power and initiate its timers at T-minus 9 minutes. I will poll the team for concurrence to enter terminal count and release the hold at 4 minutes after confirmation that the spacecraft is configured for launch at approximately 4.5 minutes. I will then inform the ULA launch director that NASA is go for launch, and the expected T0 is 10:02 in the morning. Our launch window ends at 11:45 a.m. on Saturday. Back to you, George.
All right, thank you, Omar. And now to Vernon Thorpe, the program manager for NASA missions from United Launch Alliance. Vern.
Hey, thank you, George. Good afternoon. On behalf of Michael Gass, our Chief Executive Officer, and the 3,600 men and women that I work with, United Launch Alliance is honored to be part of the team that will launch this exciting mission to Mars. This is ULA's 11th launch of this year, and MSL will mark the 56th launch for our company in just 60 months, the 5 years that we've been around. We've worked together with our NASA Launch Services program customer on 5 major launch campaigns this year. In addition to our current MSL activities, we've also launched the Aquarius, Juno, Grail, and NPP missions in just the last 5 months. Our teams have worked tremendously hard to get us to this point in the MSL campaign, and on Saturday morning, we'll be ready to launch the Curiosity rover on its 9-month journey to the Red Planet. This mission will be launched aboard an Atlas V 541 configuration vehicle, as Omar described. That includes a 5-meter fairing provided by Ruog Space, the 4 Aerojet-provided strap-on solid rocket boosters, and the RD-180 booster stage, or the Atlas booster stage, is powered by the RD-180 engine from RD Amros, and the Centaur upper stage will be powered by a single Pratt & Whitney RL-10A engine. I will now show a video that summarizes the events that we'll see on launch day, if we could roll that. Okay, you're seeing actual footage here from the Juno launch this last August that had a very similar configuration. That was a 551. The MSL mission requires 1 less SRB. We'll lift off with about 2 million pounds of thrust. Vehicle weight at this time is on the order of 1.2 million pounds. We've got a good, healthy thrust-to-weight ratio. The first major event you'll see after liftoff will be the burnout and jettison of the 4 solid rocket boosters. They'll burn out about 1.5 minutes into flight, and we'll jettison them shortly after that. A couple of minutes later, you'll see the next major event that you can see from the ground, and that will be a jettison of the 5-meter payload fairing. We'll continue to burn the booster for another minute, so 4.5 minutes total. At that point, we will have depleted the booster propellants, and we'll shut down the engine and separate that stage from the Centaur upper stage. At that point, Centaur will prepare to light its engines for the first of 2 engine burns. The first engine burn will last about 7 minutes, and it will put the Centaur with MSL on top into a low Earth parking orbit. Following that first burn, we'll enter a coast period that will last about 19.5 minutes. And after that coast, we will be in position for the second burn. That second burn will last about 8 minutes. And once that second burn is completed, we will be on an escape trajectory and on our way to Mars. 4 minutes after that second burn is completed, we'll reorient the vehicle and separate the spacecraft. So those are the events that we hope to see. Total mission duration until we separate the spacecraft will be about 42 minutes from liftoff, and that could vary a little bit depending on the actual time that we lift off. Yeah, I think it can run anywhere from about 36 to 44 minutes. I want you to know that ULA is proud to play a critical role in delivering one-of-a-kind NASA payloads to orbit in support of the global science community. We are focused on perfect product delivery for MSL and for every mission that we launch for NASA and all of our other customers. Perfect product delivery includes a relentless focus on mission success, a focus on 1 launch at a time, and continuous improvement in meeting the needs of our customers. This mission represents the culmination of years of hard work by NASA and the ULA launch teams. I believe we began integrating this mission onto Atlas in 2006. And we look forward to Curiosity's landing on the surface of Mars and to learning whether the Mars environment is capable of supporting microbial life. Thank you to all of our mission partners who have worked so hard to ensure that this mission will be a success. Back to you, George.
Thank you, Vern. And now to Pete Teisinger, the project manager for the Mars Science Laboratory from Jet Propulsion Laboratory. Pete?
Thank you, George, and good afternoon, everyone. It's a major event for us to be at this point in time with MSL and the rover Curiosity. This has been a major and long-term development, and as Colleen and Vern and Omar said, there's been a tremendous number of people that have been involved in getting us together to this point in time, and their support and their family's support has been instrumental in our success. I'd like to pick up the story where Vern has left it off. If I could see the animation, please. So this shows the ending of the sequence of Centaur burn, and puts us in the hyperbolic escape trajectory to Mars. The Centaur spins us up and then ejects us or separates us in the proper attitude for solar power and communication to Earth. The cruise to Mars is 8.5 months, and we arrive on the 5th of August in the Pacific time zone, or the 6th of August here on the East Coast in the evening. About 10 minutes out, we eject the cruise stage. We arrive at Mars at about 12,000 miles an hour. We're using guided entry, thus the small thruster flashes you see, in order to make the landing ellipse much smaller than it was on the Mars Exploration Rover project. We'll be able to land in an ellipse about 20 kilometers circular. The heat shield dissipates about 98% of the energy we get when we arrive at Mars. And around Mach 2, we will deploy the parachute. That will continue to slow us down until we go subsonic, at which point the heat shield will fall off. And we'll continue to descend to the surface until we're about a mile or mile and a half off the surface, when we drop out the descent stage with the rover underneath it. And we descend on 8 propulsive engines for that final approximately 2 to 4 kilometers. At this point, we have radar lock on the ground with the Doppler radar, which shows us both range and range rate. And approximately 200 feet off the ground, we deploy the rover along a 13-meter bridle. That's the sky crane maneuver. And then we will do a constant rate, 3/4 of a meter per second motion toward the surface. We land on the mobility system that is sent by the descent stage, which then cuts the umbilicals and then flies away about half a kilometer to 3/4 of a kilometer away, where it crashes. And so there sits Curiosity on the Martian surface, and we will not deploy. Is different from Mars Exploration Rover. We will not deploy our mast on that first day, because we'll want to assess the stability of the rover, since it's so large, on the terrain in which we've placed it. But the second day we will deploy the mast, and shortly thereafter we'll begin our science investigation. We use the cameras to select targets, and we'll be moving toward targets both in the landing ellipse and exterior to the landing ellipse. The speed of the rover is about 1/10 of a mile per hour, just as it was on MER. When we find valuable targets, we will go up to them, and both with the cameras and then with what is ChemCam, we will look and determine targets that we might want to use sampling on. We can then deploy our arm. It's about which contains about 30 kilograms or so of engineering equipment and scientific equipment at the end. Okay. We have 2 in situ instruments there that can look at alpha particle spectrometry, and also a hand lens camera. But the real reason the arm is there is to collect samples through a percussion rotary-like drill. And this shows that process, and the clock indicates that that's not real time. We would then auger material into the drill, and we'll prepare it and process it for injection into one of 2 instruments. I think this will show the injection into the Chemin instrument in the rover. The other is the SAM instrument, or Science Analysis at Mars instrument. The Chemin instrument is an X-ray diffraction instrument, and this shows the sample being being subjected to X-rays, which form an X-ray diffraction pattern on a CCD, from which crystallographic and mineralogical information can be obtained. The rover is meant to rove about 20 kilometers in its one Martian year, which is 687-day Earth day life. And so that's kind of a capsule summary of the mission. We'll talk more about that when we get to the pre-landing events. Of course, in order to get to this point in time, as we've talked about before, there's a lot of work that has to go on to take place. You were shown the buildup of the Atlas. If I can have the next animation, please. We'll talk about how the story of the rover here at Kennedy. We arrived on a C-17. We trucked some mechanical support equipment across the country from JPL in Pasadena, but we flew both the cruise stage and then on a later flight the descent stage and the rover here on C-17s from March Air Force Base in San Bernardino. The cruise stage arrived in May, and the descent stage arrived in May. Descent stage and rover arrived in June. This shows the cruise stage being spun to determine mass properties, and also as a checkout with a spin table for the later heavier mass descent stage and rover that would be required. Here's the descent stage being unwrapped from its packing protective and being inspected. The very complex piece of equipment that is roughly the same mass as the rover when it is fueled. This shows the rover in its ready to launch configuration. The final covers being removed from the wheels. This is a Pathfinder activity for installing the RTG. Shows how it was done on the pad, although in that case we did not have, of course, the fairing around it. Showing the mast being raised as final functional testing of the vehicle here took place. Okay. Here the descent stage is being placed on top of the rover. The red cages around the main landing engines are for protection. They are red for flight items. You can see here the descent vehicle, and here it is being placed into the back shell. It's actually elevated into the back shell, and here the back shell is being elevated onto the cruise stage, and then the final process is the placing of the heat shield onto the bottom of the vehicle. You can see that here. And there we have the fully built-up rover. Fully built-up vehicle, and here's the last time we got to really see it and take a picture as it was being encapsulated into fairing, and that occurred about the 2nd of November. No, excuse me, about the 24th of October, and then it was shipped to launch site 41 when it was boosted onto the rocket on the 2nd of November. We've had a tremendous experience here in Florida. The support from the Kennedy Center and from the NASA part of that, supporting the launch vehicle operations, and from ULA has been superb. We've had our kind of normal challenges and hiccups that we have in these kinds of major operations, but things have gone extremely smoothly, and we are fully prepared to go on Saturday morning, and we hope that the weather cooperates. George.
Thank you, Pete. And now for the weather forecast on Saturday, our launch weather officer from the U.S. Air Force 45th Weather Squadron, Joel Tombiolo. Joel.
Thank you, George. Good afternoon, everyone. Well, basically between now and Saturday morning, we will have a few weather changes that take place. If I could have the current satellite picture up to show you what the current conditions are. You can see that band of clouds stretching across the state, east to west. We have a cold front that's moving down the state, and the above normal temperatures and humidity we've been experiencing over the last few days will end. This will be the last day for that. That cold front is expected to move through the area this evening and maybe throughout the overnight hours. Now what we'll see once that cold front moves through, the winds will shift in a clockwise fashion, basically from the southwest, which they are right now, all the way around to more of an easterly wind by the time we get to Saturday morning. So we're going to have that little bit of change. The wind speeds after the cold front moves through will be gusty. They'll be probably well into the 20s over the next 2 or 3 days, but are not expected to exceed any of the launch vehicle constraints or liftoff constraints as we get closer to launch. The other thing that we're going to be monitoring, a typical scenario, what we see here once a cold front moves through, is that once the winds shift all the way around to the northeast and east, and the cooler air behind the front moves over the warmer ocean, we tend to get a lot of low-level, not what we call flat clouds, or low-level clouds form over the ocean. And because of the eventual northeast and east winds, some of those clouds could move on shore as we get into a Friday and Saturday time frame. And we're going to be monitoring those lower-level clouds moving over the launch site for cloud ceilings and a couple of our triggered lightning rules. As we get into Friday morning for the roll out to the pad, not anticipating any concerns. Again, the winds at that time will probably be out of the northeast. They will be gusting in the 20s, but again, not expected to exceed any roll constraints, and we're certainly not anticipating any lightning or things of that nature during that time frame. Once we get into Saturday morning, the forecast, the winds will continue to shift around to the east. Right now we're looking at wind speeds being on the order of 20 knots, gusting to 24. Again, that will be below the wind threshold, liftoff threshold. Right now the forecast cloud cover is a scattered deck at 3,500 feet. Now there is a mission flight rule that states that if it becomes a ceiling, or in other words, if the clouds become broken or greater in terms of cloud coverage, if that ceiling of that clouds is 6,000 feet or less, then they have to go through some more observation to be able to continue on with the launch, because they need to see the launch vehicle off the pad and through a certain amount of time. But the cloud forecast is for not to have that violated. Again, a scattered deck at 3,500 feet and another scattered deck at around 30,000 feet. The other constraint for the mission flight rule is a ceiling of 4 miles, but we're anticipating 7 miles visibility, so we're not looking at any problems there. There could be a couple showers over the ocean whenever we have the winds and cooler air moving off the ocean. Not only do we have these clouds form, but there could be a few light showers in the area, so we'll be monitoring that. And right now the temperature at liftoff is expected to be in the low 70s, between 71 and 72 degrees. And right now the overall probability of violation is 30%, with the two concerns being the cumulus cloud rule, which is a triggered lightning rule, and that cloud ceilings of being 6,000 feet or lower. If we were to go into the next day on Sunday, that winds will continue a clockwise shift and become more southeasterly on Sunday. Other than that, pretty much the same weather conditions that we're going to see on Saturday. The clouds will still be at, the lowest cloud deck is expected to be around 3,000 feet that day, but still scattered. Again, you have to have a broken deck or greater for a cloud ceiling to be an issue. Good visibility. The winds will be more out of the southeast, a little bit weaker, 16 peaking to 22 knots, and the temperature about the same, 71 to 73 degrees. And as is the case on Saturday morning, the overall probability of constraint violation on Sunday morning, if needed, would be 30%. Now, if we were to go into Monday, conditions deteriorate. Our next cold front is expected to move into Florida on Monday time frame. So because of that, we'll be looking at higher winds and a lot more of our cloud rules being violated. And we're going to be looking at a 70% chance of violation. And again, that only holds true if we were to have a 2-day slip into Monday morning. But right now, Saturday conditions look good. We're just going to be monitoring the clouds, make sure the ceilings aren't too low, and there's no showers moving overhead. And other than that, we'll be in good shape. That concludes, George. Thanks.
All right. Thank you, Joel. We're ready now to take questions. So please give your name and affiliation when the microphone comes to you. We'll start here in the front with Marcia.
Marcia Dunn, Associated Press, for Mr. Theisinger. You mentioned a 20-kilometer odometer reading you're hoping for during the prime mission. How much more could the rover travel, and how does 20 kilometers compare to some of the other rovers and what they actually achieved?
Well, the requirement for MER was 1 kilometer, and of course we've been much more successful than that. The requirement for Curiosity is 20 kilometers. We test mechanism equipment to 2 times and 3 times life, and so we've actually tested the actuators that drive the motors to an equivalent distance of 40 kilometers, and then in fact have done cold temperature testing even beyond that. There really is no life-limiting characteristic of the rover in terms of something that we know that will run out of a consumable in some period of time. It's a question of wear out, and so we'll see how it really plays. You know, we have a set of requirements, and we tested those requirements plus some margin, and we don't test a failure, so we can't really tell you what the expected life might be.
Ken?
Hi, Ken Kramer for Spaceflight Magazine. Excuse me. First, congratulations to all of you. My question is also for Pete. I wonder if you could describe the first few days of the operations you'll be doing. When can we expect the first pictures, and when would be the first motion of the rover?
We're actually going through a lot of activity right now to talk about the characterization of the phase of the mission. When we first land, we'll want to ascertain the integrity of the vehicle, since we will not have seen it in that state for almost a year. And we'll want to ascertain the stability of where it is located and what kind of surrounding terrain we have. And so we'll go through that health assessment. Then we will engage in a set of first-time activities. Clearly, we'll get pictures from the mast. We would expect the day after landing. We will, I think at that point, shortly thereafter, we'll try to exercise the arm in its motion, but not certainly in sample acquisition. I expect us to drive inside the first week, if nothing else, to get away from the landing zone where there might have been contamination from the engines. After that, it will depend very much on the state at which we see things, and also the science targets. We could land very close to something attractive. We could land quite distant from something attractive. We would have to decide, that would be the facts on the ground as we would see it. I would not expect us to take a sample and try and ingest it into SAM and Chemin for quite some time, possibly as long as 2 or 3 months after we actually land. But the other science instruments will start right away. Things like the RAD and the DAN, which measure subsurface hydrogen. Those are passive instruments. I would expect us to start those investigations right away. So it'll be a mixed bag in terms of when the science comes out.
Bill?
Bill Horowitz, CBS News. 2 quick ones. They're sort of related. I think they're for Pete, although Colleen might jump in too. First is a simple reporter question. We've all been reading that this is the most complex lander ever sent to another planet. And I'm wondering, do you guys include Apollo lunar landers in that? I mean, do I need to put the word robotic in front of that when I say this is the most complex mission ever sent?
I would if I were you.
Okay. Then the related question is the risk-benefit on this mission. I mean, everybody sees that landing sequence, and to the untrained eye, it just looks crazy. And I realize you guys think that this is great, and it's a great way to do this. And it just seems like there's a big risk with a mission like this, and there's a huge payoff with a mission like this. There's both of them at once. I mean, how do you characterize that, the risk and the benefit?
Well, I think the characterization of the benefit versus the investment that the agency wants to make is what Colleen can speak to and the agency can speak to. My job is to make the risk as small as I can possibly make it, given that that's the job we've been asked to do. And to tell them if we think that risk is unacceptably high. Okay, I think that we have done the same kind of due diligence on this mission that we did on MER and we do on all our space missions. We've done all the testing that we thought we needed to do. We've done all the analysis. Your impression of the sky crane is not alone. There are a lot of people who look at that and say, what are you thinking? And we have done a tremendous amount of review and analysis and independent review of that approach from the very beginning. One of the first questions we asked ourselves was, how are we going to test this? Okay, and we went outside of NASA and into a whole bunch of other people that do this kind of work to try and get that ascertained, and that was successfully. I mean, we put together a test program that we feel has successfully validated that from a design standpoint it will work. We're doing 50+ pyro events, and we're doing a lot of things. So from a standpoint of if something decides to break at that point in time, we're in trouble. But we've done everything we can think of to do. Yes, this is the most complicated mission we've attempted on the surface of Mars. The science kind of demands that. This kind of sampling science and the science that we want to obtain has required sophisticated sampling mechanisms, has required a long life rover, has required a long traverse distance, has required a large rover, and that's required a complicated entry, descent, and landing system. And so that whole string kind of goes together. Now, if Colleen wants to talk about the benefit versus investment.
Sure. Bill, I think one thing the agency looks at is the path that we have going forward. And so first off, this is the most interesting science we could possibly do. And then how it converges with other missions that NASA's trying to undertake. And because we can, after this, have a vehicle that we can land safely on the surface of another body that's 900 kilograms, that we really can't do any other way, then that's part of the risk that we think is worth it. And then, as Pete said, we have an enormous amount of risk reviews where we look both internally and externally at any kind of mitigation we can do. We look at what's called residual risks, and we look then at the 100,000-foot picture and say, if you will, for this, and say, is this really a good bet that it'll work? And we did each of those on the Mars Science Lab. We said yes to each of those, and that's what's brought us here today.
Justin?
Justin Ray with spaceflightnow.com. Also for Pete, I was wondering if you could talk to us a little bit about the communications plan during entry and descent and landing, what you will actually be knowing in real time during entry.
Well, I think we're in much better shape than we were with MER, and we're in the same kind of shape we were with Phoenix. So we will have overflights of the landing area by both Odyssey and Mars Reconnaissance Orbiter, and we will have a UHF communication at high rate from those assets, from the MSL spacecraft and Curiosity to those assets from the start of entry, descent, and landing all the way to the ground. There is a second overflight, I believe, of Odyssey about an hour later, and so we'll be able to get a short amount of data on a health check basis at that point in time as well. We have X-band tones. If you remember MER, we use the subcarrier frequency to set toes to the ground on X-band. Because the Earth is actually set at our landing site by the time we get there, we won't get tones to the ground, but we will get tones through parachute deploy. So we've got very good communication coverage for the entry, descent, and landing event. The Odyssey relay will be a bent pipe, so we'll get that in real time. The MRO relay is a store and forward, so that will be played back immediately after the landing.
Oh yeah, hi, Mike Wall from space.com. Yeah, this has been a long time coming. Obviously, you guys started working on this in about 2003, and you had a 2-year launch slip back in 2009. I was just wondering if you could just kind of say, what does it feel like now to just be a few days away from launch after this extremely long and involved process? How does it feel sitting up there talking about this is actually going to happen in a few days?
Well, I think it feels tremendous to have completed all this work and to have the risk situation being what we think is in very good shape for this kind of thing. Not perfect, obviously there is major risk to these things, but we're in pretty good shape. I think if you ask each individual person, they'll provide a slightly different answer depending on how finished they think they are. With me, I wait for the range to tell me it's green about a minute before we go, before I finally decide that we're really going to do this today. The people who are worried about landing and worried about the surface mission, they consider this prologue. Okay, this is necessary but not sufficient for them to get their jobs done, and they've got a lot of work to do during the cruise to get ready for that. But I think you could visibly see the team morale improve. The team grin more, the team smile more as the rover and the vehicle came closer, more and more together here when we were at Kennedy. Every time Dave Rule, our ATLO manager, would send a string of pictures back to Pasadena, and we saw more and more of the vehicle being put together. Every time we saw a picture of Pad 41 and we saw, the Atlas being built, you feel like, yeah, it's really here. We're really going to do it this time. We're ready to go. So, yeah, there are a lot of grins around, that's for sure.
Greg?
Craig Cavalt with Aerospace America. First, a question for the launcher guys, and then a question for Pete. I guess it's Omar and Vern. Some launchers are so important that well in their parts selection there's a extra effort to pick components that have the very highest test results as all the component testing goes on. Is that a process that was used with MSL launcher, or is it the basic standard components for MSL's Atlas V?
The answer is that on this vehicle we have our standard criteria that components have to pass to be qualified for flight. And that's okay because that standard is extremely high. I mean, you're absolutely right. This is a critical, important launch. One of the ways that we stay successful is we treat every mission like that. I don't want that to sound like kind of a flippant answer. We really do treat it like that. If there is a component that is suspect or doesn't pass the screening or test criteria on any of our missions, whether it's somebody's 30th communications satellite or a critical one-of-a-kind mission like this, it's not going to get on that rocket. And that's a standard that we set for ourselves. Our NASA customer works with us to make sure that that standard is enforced. So the basic answer is there wasn't anything unique done for this mission because we already have the high standards in place it takes to be successful.
Jay?
And for Pete, when you and I last visited at JPL about 18 months ago, you said experience in building the rover so far to that time showed serious problems in the U.S. aerospace parts fabrication sector, if you will. Can you expand upon that now that the assembly, all the parts selections are complete and you're here on the pad? Explain further what you meant by that.
Yeah, I think that, first of all, this is Pete's point of view. Okay, this is not necessarily NASA or JPL's point of view. But I feel that, we've had quality incidents through the building of the rover in larger numbers than we've had in the past when I was a much younger engineer building these kinds of equipment. And I think the result of that has been stress on our schedules and our funding. I don't think that has resulted in a less adequate product. I think that Vern is absolutely correct. We have quality standards and mission assurance plans that we put in place, and we follow those very rigorously, and we do not deviate from those. We may detect problems that we then have to go off and solve as a result of those things, but that does not mean that we accept a quality shortfall as a result of whatever issues we kind of come up with. You know, we had problems with the actuators. We solved those. We've had problems with other piece parts. We've solved those. I'm very, very happy with the quality that's in the rover. I think that, you know, in terms of the number of problem failure reports and the number of waivers we've signed, we have no waivers with dissent on this vehicle. And the number of red flag PFRs, unverified failures, we're very much in family with where we were on Cassini, and we're very much in family with where we were on Mars Exploration Rover. So I think in my point of view, it's a tougher road to hoe a little bit to get to there, but the quality of the product when you get there is as it's been in the past.
Jay? I'm sorry, Craig, we're running short of time. We have to
Hey.
be out in 5 minutes. So, Jay, we'll go to
Jay
you.
Barbary with NBC. Yeah. What is the average temperature in Fahrenheit at Gale Crater when Curiosity will be operating, and what is the temperature range on Mars, the latest that you have in Fahrenheit? Can you tell me that?
I'm sorry, I'm a centigrade guy. I'm Fahrenheit on Earth, but I'm centigrade on Mars. So somebody will.
In Fahrenheit instead of Celsius, could you tell me what will be the range that Curiosity will be working in Gale Crater?
Okay, the cold temperatures at night can get down below about minus 100 degrees centigrade.
About what?
Minus 100 degrees centigrade. Centigrade. Okay.
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 I've got to go convert it. Go
Yeah,
ahead.
you've got to go convert it. We'll be able to operate the rover. We need to heat up the actuators in order to move and do mobility, and we'll be able to start doing that when it's about minus 60 or minus 50 degrees centigrade. Okay, 50 or 60. During the day, it gets up to 0, minus 10, 0, plus 10, plus 20, depending upon the season and a variety of other factors.
Okay, thank you.
All right, Todd?
Todd Halverson of Florida Today, one for Joel and I guess one for Omar. Joel, I was wondering about the onshore flow that you anticipate seeing and your weather criteria for toxics and the potential for, plume that might blow over, a surrounding community. And I was wondering if you do anything different with an RTG on board, or if there are any special weather criteria for RTGs. And for Omar, I was wondering if you could explain the windows or the launch opportunities within the window. If you don't get off at 10:02, how your opportunities fall out from that time to the end of the window. Thanks.
I'll go first. As far as the wind flow, yes, it's pretty much going to be due east to west on that day, 100 degrees. To my knowledge, there's not anything different what we call the Risk Assessment Center does as far as a potential plume. But again, they take the real-time weather data from the balloons that we released during the countdown, the lowest few thousand feet, and they'll adjust their model accordingly based on the wind flow, and they'll look at short-term wind flow projections to see if any changes are expected. But other than that, I don't, again, correct me if I'm wrong up on the panel, but I don't believe there's anything in addition, plume-wise, that they'll do just because of the RTG on board.
And just real quickly, at what time do you come no-go because of the potential for toxics? What's the cutoff there?
I believe it all depends on when the balloon releases. I'm not sure the exact time and how late in the count, but whenever after we release a balloon, they will get the data and their model will project what the plume would do, and if it violates their criteria, then they would go, no-go. I don't believe it depends. It matters at what time of the count that occurs. Again, it's going to be basically after each balloon is released.
Okay, and you had a question for Omar?
Yes.
Yeah, as far as launch window management, what we have done is we've analyzed 5-minute segments. So every 5 minutes we have an opportunity. We do have a limitation because the spacecraft does have some onboard timers that have to be reset. So we need about 14 minutes between opportunities to be able to have the spacecraft reconfigure, get back on external power, set their timers, and get back on internal power. So we've analyzed every 5 minutes throughout that window, and do have some lag time depending on how deep we get inside of T-minus 11 minutes.
Right here, this will be the last one.
Gene McCulka with Talking Space. This might be for Colleen. Article this week said that this might be the last of the larger deep space exploration missions because of the plutonium-238 issue, meaning, with the fuel shortage. Are we really, how bad is it? Are we really at a crossroads here with a different power source, or are we looking at alternate power sources if the production of plutonium-238 isn't approved?
Well, the natural decay of plutonium-238 is certainly one of the preferred ways of going, and the Congress is looking at providing funding to start up for the Department of Energy a new plutonium-238 line. In addition, NASA for some time has been investigating and investing in alternative ways of doing some of these missions, and that includes ion propulsion. The Dawn mission that I mentioned that had gone to Vesta and will then go on to Ceres is ion propulsed. That's a unique way of using propulsion. So we're looking at alternate ways for power and propulsion. But Certainly when you are doing something like the Curiosity rover is doing and trying to rove on a planet day and night and do a kind of intense investigation, it is the preferred way. And we don't predict at this stage that we'll have any trouble making sure that the United States and NASA has enough plutonium-238. So we're working it.
All right, thank you, Colleen. And we're going to end the briefing here. We have a bit of a time constraint because we need to turn the satellite around and send it to Houston because we have another briefing coming up right here at 2 o'clock. One programming note as far as launch coverage on launch day, because of the change in the launch time to 10:02, we will be starting coverage at 7:30, which is a half an hour earlier than we had originally advertised. So we have our next briefing in about 10 minutes, and thank you very much for coming.